Okay, we have sound. We're on time. Nice to see you. Nice to be here. So today we're going to talk about cookies and why we are returning authentication cookies. Or the formal title is probably better: introducing BFF, Backend For Frontend pattern. But I prefer return of the authentication cookie. So I'm Anders. I've been working with login buttons, if you want to say that, for about a decade. I've been focusing on that. Nowadays I work with vendor software and identity server, doing training, speaking, consulting, etc. I also have a background doing SAML 2, which is the short version. SAML 2 is a protocol you shouldn't use. That's my notion of having spent 10 years learning it deeply. But today the focus is on single-page applications and authentication cookies and session management. If we start from the beginning with the web, the early days of the web, the really early days, we had this pop-up coming up asking for username and password, and we were doing basic authentication. But then fairly quickly we moved along to the username and password being entered on the web page. And we had a button login where we posted the username and password to the server. The server had some action, some stuff where it processed this and validated the username and password according to all security best practices. And it's done. And then HTTP is a stateless protocol. So what happens when our browser makes the next request? If we just validated that on the server side, the next request that comes in, the web server is like, who are you? Who did you find me? So what did we do? I have a special prize for anyone who can tell me what we give the web server to make it happy. Cookies. Okay, who was the first one? I think, here, cookies. Here you go, some cookies for you. Exactly. And then the web server is happy. Are you equally happy looking like that? Great. Back then, we already had these cookie consent screens built into the browser. And then everybody deactivated them because there were so many cookies. And things were fine. We had our server-side rendered HTML pages, our server-side processing, all worked well and nice. And then one day, maybe 2004, 5, 6, I don't remember exactly, I went to a Swedish map service and was astonished. It was possible to pan and zoom on the page without reloading the page. It was smooth, it was client-side. What was the secret? Well, the secret was XML HTTP request, or Ajax. Of course, it wasn't XML. Do you know why it's named XML, HTTP request? Thing is that if you create some modern piece of technology now and want management buy-in or investors or anything, you need to put in AI, machine learning, and blockchain technology. If you don't have those three, there will be no management approval for the technology. This was back in the XML age. They had to tack on XML just to get XML approval. And also, the actual code was done by the MS XML team from the start. So it's just a marketing thing. And we were happy. We were doing a lot of nicely looking applications with the new powers of the client side, libraries being able to do full requests. And we were really recreating client server with the web browser as being the client. And everything was nice. So one day in these nice times, I was sitting late at night at home, reading some web forum, and found a security researcher on that forum asking, do I know anyone who has one of these modems? This was a fairly common ADSL modem in Sweden. There were like 200 or 300,000 out there. And I said, yes, I have. And then I got a private message from that security researcher saying, hey, nice. I've created a web page here. Can you please try to visit this web page? And I was like, sorry. First of all, I should mention that we on this modem we had a setting with DNS settings where we could set up primary, secondary, and it just saved some action when we wanted to change it. So I said that yes, I have this modem, and he sent along the address to his web page. He said, "Do you want to visit this one?" And I said like, okay, what do you think I did? Of course, I checked the website. Who wouldn't? And I came to a page with kittens. Literally, he had made a page with a picture of kittens. Not exactly these kittens, but there were kittens. And that was, okay, it's safe. And then I started to think about it. Okay, wait a little. He made a post on a security forum asking for people having specific kind of modem. He sent me a private message. He also said that please do not tell anyone before I've published this. And then he wanted me to check a URL. So I checked the page source. Thing is, these are not nice kittens. These are evil kittens. Because they come with a hidden iframe that submitted a form automatically to my modem, changing the DNS servers on my home network. And they did this because, of course, the cookie was sent along, because the authentication cookie was at these times sent based on the target only. So it didn't matter who the origin was. And the flawed security model here was, I mean, I was thinking I was secure. I was sitting on my home network. These pages were only available from the my home internal network. I mean, how could the evil kittens out on the internet attack my modem? It shouldn't be possible. But well, it is with the cross-site request forgery attack, because the evil kittens make my browser render that page. My computer makes the request to the modem. And with these were also the days before HTTPS was used everywhere. So with the security researcher controlling my DNS on my entire home network, I started to see funny things on when visiting newspaper sites, because he had hijacked them and filtered them, etc. Eventually, he ended up getting this published on the real paper print of one of the major Swedish newspapers. So it was a really great research job. It was not so great for Bredbandsbolaget, who had to close down 200,000 customers' configuration options. So what do we do to... So what we've learned now is that cookies on the one hand are convenient because they are simple, or sorry, they are delicious. They are, sorry, I'm bad for your health if you eat too many. They are simple because they are auto-transmitted with every request they're transmitted, but they are also bad because they are auto-transmitted. So due to cross-site request forgery, we had to do something else. What did we go for instead of not cookies? What did we pick up instead? And switch to for authentication. Yes? Generating a CSRF token, or even switching to tokens altogether. So is this tokens? We can say so. Yeah, deliberately transmitted tokens. And when we had to create a token, why not use that for authentication all the way? And then the Auth2 implicit flow was born. The Auth2 implicit flow is a way for the single page application to get hold of a token that it can then send off with every API request. So what it did is that the single page application requests a token. The token is attached on the query string on a callback on the redirect back. And the client stores and manages them as securely as it can in a browser, and then attaches to any outbound calls. This approach has a number of drawbacks. One is that a URL is usually logged or ends up in browser history, etc. We do not want our sensitive tokens being stored anywhere. Referrer headers. This also has no protection against token injection attacks where we want to really force someone to log in as someone else. This is a class of attack where that is reasonable. I mean, if you have what can we say, sensitive data, online therapy site. If you're doing online therapy, you have an online therapy site where you enter your inner thoughts and save them. What if I can make you save them to my account so I can go read your data because you saved your important data to my account? So we need to consider both the case that I do not want someone else to log into my account, but I also want to be sure I am logged into my account and not someone else's account when I do save sensitive data. This flow has no protection against that. So we went further with the authorization code flow with proof key code exchange, which is better. We are now making the front channel call, the redirect back, forth. We get something called an authorization code back representing the authorization event. And then we exchange that over back channel for the actual tokens. We store and manage the tokens. So this solved the PXE flow, or authorization code flow with PXE is really great. It solves the security issues. It is what we are still using on server side. So it handles the token exchange and handshake. But what it doesn't handle is token storage. I mean, the browser, is it a secured computing environment? We have cross-site scripting, we have rogue plugins, etc. I had a great plugin for Chrome. It was a plugin that allowed you to screen dump and create a screen dump of the entire page, not just the visible area. Do anyone remember this? And then a rogue person bought that tool and injected spyware in a widely deployed plugin that had privileges to read page contents of every single page. So that's why we do not trust the browser. So let's have a look. What do we do on a server-side application that we can trust a bit more? A server, well, it requests tokens. Sorry, I should say here. So what we do here to handle that, the remedy is really on the client side that we are making the tokens extremely short-lived, like 5 minutes. And every 5 minutes, we need to renew them via silent renew mechanism, which means that if someone manages to steal the token, it is just valid for a few minutes. And after that, it's expired, and we are fine. And then we need to renew them. So what do we do on the server side? On the server side, we do the same dance. We request tokens. We get back 2 tokens, the yellow access token and the blue refresh token. We store them on the server side. We use the access token to call APIs. The access token is still short-lived because we are sending it on the wire to every API we are accessing. So with something being widespread, and it is also self-contained token, meaning that anyone that gets hold of this can just use it. There is no way to revoke an access token once it's in the wild. There should still be short-lived. And then we want a way for the server, when this is expired, to get a new token. And that's where the refresh token is used. The refresh token, the server calls the authorization service with the refresh token and asks for a new access token that it can then use in subsequent calls. And this way, the user do not have to re-log in every 5 minutes. That would be kind of awkward, wouldn't it? So this is great. But what about client-side applications? Can we use the same approach for a single-page application in a good way? Well, we could. There are people doing it, but we still have the issue of storing and manage tokens. The server-side application is running on the server in our data center under our control. It's a secure environment to store the tokens, while in the browser, not so much. So what did we do for browsers? Well, the idea was simple. If we have a single-page application, we render a small hidden iframe. This small hidden iframe renders a page from the authorization server where it sets request tokens with prompt equal none setting, meaning that this should just reuse the existing session. Don't show any UI. I mean, a UI in the hidden iframe wouldn't be visible. But as long as we have an ongoing single sign-on session, it works. How is that session represented? How does the authorization server know that there is actually a session going on? What is sent along? Cookie, who was, I heard it from, you were the first one? Sorry, I need to check. Now we are in modern times. Do you consent to the cookies? Okay, here you are. So while this was happening, we also had another thing happening on the same time. And that was, you remember the kittens? Wait, why don't we do a demo first before we show the kittens? Let's do a demo on how this works with the hidden iframe. So I have whipped up an excellent web application to show off my HTML design skills. You have high expectations now, don't you? Okay, I have a demo here. I'll need a mouse to be able to scroll. So if I click here, log in, I'm redirected to the identity server, where I can now log in as Alice, and I'm back. I can call APIs, and I can log out. I can even call some of the APIs are callable publicly, but tomorrow's forecaster is only for logged in users. If I log in again, sorry. On this particular host, I have, you remember we said we should have short-lived tokens. So 5 minutes is a reasonable real-life scenario. My identity server has 10 seconds. So when I try to call the API again, it doesn't work, but I can renew the token silently and then it works. Usually this renew token happens in the background, but then I wouldn't be able to demo that it didn't work. So let's look at what we have here. In the browser DevTools, elements, when I press renew token, do you see here, it flashes by that a hidden small iframe is quickly appearing and removed. There's also another neat thing done with this, and that is log out. There is a hidden iframe all the time that checks that the session is still available on the server. So this is like magic. If I click here and click log out, yes, I want to log out. I didn't click on the left side. It automatically detects I'm logged out within a few seconds. And this is great. This is about the best user experience that can happen, that we can have. Until, do you know about Safari? I don't have Safari, so I have to run with Chrome, but I'm using this block third-party cookies. Safari has it by default. Chrome is, they've said they want to block it next year. But the thing is that third-party cookies are really used for two things. One is authentication, distributed authentication, and one is tracking people for advertisement and ad networks. So Apple, they care about privacy. They make their money off selling stuff, selling hardware. Google cares kind of about privacy, and they make their money off internet ads. So they need to find a way to block cookies for privacy without breaking the revenue stream. But let's see if we go to the same, run the same application here. I click login. I log in as Alice. I'm logged in as Alice. I'm happy and I'm signed out. I signed in, didn't I? Let's try again. Sign in. Just focus by. What happened? Okay. Browser DevTools to the rescue. Network. Login. And we can see a number of things happening. What I want to show you is this one, check session. So let's go to this one, which is the non in privacy mode. This is the one where cross-domain cookies are allowed. If I go to the call to check session, I can see that the identity server session cookie is sent along in the hidden iframe. And that is how the hidden iframe detects that we have a session. As long as that cookie is there, it detects we have a session. When the cookie is gone, it means we signed out. And it indicates back to the hosting application that we are now signed out. Let's see here, check session. Do you see the cookie? It's small, but I don't see the cookie. Thing is, that cookie was blocked because it's a third-party request. So this elegant user experience we had that is so nice is simply broken for good by the browser vendors. And this isn't a question about a bug or something we can fix in the library. The entire mechanisms that the OpenID Connect session management spec is built around, those mechanisms are gone or broken. We need to do something else. So, in the meantime, while this happened, things were also changed. Other things were also changing in the browser. And now let's see if I can get back to extend mode. And the slideshow. Sorry, I need to start this. Yeah. So remember the evil kittens. Doing the cross-site request forgery attack on my modem. That was happening because of the cookie. But before the browsers implemented these cookie limitations, they also implemented something else, SameSite mode cookies. So previously, the kittens rely on the fact that the cookie is submitted solely based on the destination address. The browser doesn't validate that it's the kitten sending the cookie and not me having loaded the real settings form of the modem. With SameSite strict, that is changed. So the cookie is no longer sent. And looking at browser support, we can see that it looks okay. The colors are not that good, but the darkest thing is green. These are really the browsers that are important. All the browsers that are the major ones support SameSite mode cookies for current and previous and the recent versions. Based on this, the OAuth 2 consortium came out with new recommendations on how to do OAuth 2 in the browser. For simple architectures, something served from the same domain, use a cookie instead. So the OAuth 2 best practice for browser-based apps is to don't do OAuth 2. Use a cookie instead. And they even have some ASCII art in the spec on how to set this up. This is from the RFC, isn't it brilliant? Where it says that the browser should interact with the application server, and then there is a redirect to the authorization endpoint, of course, because the browser should display the login prompt on the login server. But after that, all interaction takes place through the application server. And this is described as the Backend For Frontend or BFF pattern, where we keep the tokens outside of the JavaScript, out of reach for JavaScript. To implement this, we need a BFF host. A BFF host needs a bunch of components. It needs an OpenID Connect client library. I know where we have one. In ASP.NET Core, we have add OpenID Connect, the built-in library. We need a session management tool. Well, I know where we have one. We have the cookie handling for session management in ASP.NET Core. We do need token management. We need to have renewal of tokens, storage of tokens, attaching tokens to outbound calls, etc. The open source identity model package can do that. We need local and remote API endpoints. I mean, that's a normal web API, isn't it? And for remote endpoints, we can use the YARP proxy to send off calls to a remote host. And we need some UI assets, I mean, that can just be served out with static files. We need those. So these are the components that can be used and that you can use to build a Backend For Frontend pattern using ASP.NET Core tooling. At Duende, we already did this, and it's part of our identity server licensing packages. So I want to show you a bit how we use this, and also a demo, and I want to convert my application to using BFF. So I'll go quickly through just the parts of what we will need to do on our backend. Our backend will need to add OpenID Connect setup. We will get 2 new endpoints, log in and log out, where we simply can redirect the user when we want to log in and log out. We will need some session handling with SameSite strict we can now set. We'll get a new endpoint on BFF, get BFF/user, where we can get the currently logged in user information about that. And we can, the problem here is when we set up the session to use sliding expiration, it means that the sliding expiration notion of that is that if I leave the computer and I'm not active, my site should be logged out, right? And that is done by the cookie being valid for like 30 minutes or 1 hour. And after half that time, if I make a request, a new cookie is issued, so I get another hour. And that works nice. But if I want to check from the client side if the user is signed out, I need to make requests. And I do not want my automatic request to check if I am signed in to actually slide the session. That would be quite awkward. So we added parameter slide equals false that you can add to this endpoint to indicate that this request should not slide the session. This request is actually something we want to use to check if the session is expired. We also have support for back-channel logout notifications. And this really is the future. Even for server-side applications, the front channel logout mechanism relies on hidden iframes. So if we can make login work on server-side applications with cookies, despite the cookie limitations, but we cannot make logout work smoothly because that also relies on hidden iframes. So what we have is the BFF component offers a local API endpoint. That's also important. If you are developing a single-page application, we have this idea that we have generic single-page applications calling generic APIs. And we have a bunch of APIs over here, and our single-page applications call all of those APIs equally. And the APIs are totally independent of and provide generic functionality that our applications can call. Is it that way in the real world? No. Half of those APIs, at least half, are application specific. Because we are just using that functionality on one specific application, right? So why not simply implement those APIs on the local BFF and not defer it further? So I think I have another. How do this call being authenticated? Cookies. Who want more cookies? Of course, I've cookies. Do you consent to do the cookies? Okay, good. Yeah, cookies. Are you protecting your cookies from the evil kittens? Did you verify that your cookies are SameSite? You consent it to them, yes, of course, but if they are not SameSite strict cookies, the kittens can steal them. The problem here is that this gentleman may not have read the Swedish list of ingredients yet to verify that it's SameSite strict, and people may not have up-to-date browsers. There are people running old browsers without SameSite support that could still be vulnerable. So in the Duende component, we added a simple cross-site request forgery header, xcsrf:1. Okay, is that secure? It actually is. Because the evil kittens, they are prohibited by course policy to make direct API requests to the BFF. The BFF do not have a course policy allowing third-party domains to make JavaScript API requests. The only thing the evil kittens can do is to render a hidden iframe that posts something to our BFF. And when we have a normal form post, we cannot attach headers to it. We cannot add headers. So if the header is present, we can know that this came from a JavaScript. And thanks to course, we can know that then it must be a same domain request. So that's enough. And then we, of course, have the remote APIs. Remember I said roughly half of the APIs are application-specific. The other half, they get proxied through to the actual API producer. And during that proxying of the request, the relevant access token is attached for us. We do not have to do that ourselves. So let's see if we can. We have a bit more than 20. We have like 27 minutes, right? Let's see if we can make this conversion. So I need to just tell you a bit more about the config. We also set up use endpoints. This is how we configure this. In the setup, we have map controllers. We map our local APIs. We map up login, logout user, the management BFF internal endpoints, and we map the remote API endpoints. So back to some code. And I have my running example here. And that is still not displaying there. We duplicate it. So now I'm happy. I could, of course, have served my. I could have. Let's see here. Close all but this. Close. I could have served my SPA from CDN, the Content Delivery Network. But I'm lucky. I created a very, very small ASP.NET Core web application that serves my SPA, single page application. So I already have an ASP.NET Core environment where I can add the stuff needed for the BFF. The first thing we want to do is we need to set up so that we have authentication, server-side authentication. Builder.services.add authentication. We need to add the cookie. Let's call the scheme cookie, and we want cookie.SameSite equals same site mode strict. That's good. Then let's add open. Okay, I need some NuGet packages, and I cheated a bit, so they are commented out in my project file. I'm adding the Duende BFF, YARP, and Microsoft ASP.NET Core Authentication OpenID Connect packages. Add OpenID Connect. Let's call it OIDC, the scheme. Authority. Now we want to move these settings that we already have in the single page application. We want to move those over to the server-side application. So the authority is there, opt.authority, authority equals https://other host 5010. Client ID, we can still use the same SPA. We can, opt.client ID. And the semicolons in here. We need, now when we do this, move to server side, we can have a server side secret. If I make this somewhat smaller, can you still see at the back? Okay. Opt.response type, we want the code flow. Opt.response mode, we want query string response mode. We want to say that we should be able to call an API. We want to say that we get a refresh token. And for historical reasons, that's called offline access. And we want to have get claims from user info endpoint true. We want to save the incoming tokens. It's a good idea. We want to map inbound claims true. This means map inbound claims. This is my favorite settings. You know that I was ranting about the XML-H. So the identity team at Microsoft, is anyone from the Microsoft identity team in the room? No, good. Okay, the identity team at Microsoft are stuck in XML-H. They think that we want our claims to be this long, http://XML schema soap or va. I want a simple name. In OpenID Connect, in the incoming tokens, the names are short, nice, and simple. So if we set map inbound claims to false, we say keep our short, simple, nice names, don't mess them up. When we do that, we also unfortunately need to set up some token validation parameters because the token validation parameters still by default look at the awkward XML names. So now we need to tell the token validation parameters that the name claim type is name and the role claim type is role and nothing else. Thank you. Finally, we need to tell this that if we are signing out, the sign out scheme that we should call if there is an incoming sign out request is cookie. Speaking of that, we need to set up the wire up the schemes, authentication schemes correctly too. We have opt default authenticate default scheme. The default scheme is what we are using to keep to the main session of the application. When we want to log in, that is in authentication service lingo called challenge. So the scheme, when we want to sign in, we want to do that using the OIDC scheme. And we need to set, we can set the default sign out scheme to should be OIDC as well to work. So we've set up that. We need more services. We need builder services.add authorization. We need builder services.add BFF. And we want to add the remote APIs as well. And that one is in another namespace. Done. That's all the services. Now let's set up the pipeline. You know, we are always serving static files first because we do not want to fiddle around with authentication and that overhead when we just want to return a JavaScript asset. So let's leave these first, and then app.use routing. We want to app.use authentication. Then the BFF should go in between here before app.use authorization. And finally, we are defining our endpoints. Use endpoints. Endpoints. We want to map the BFF management endpoints to get /BFF/login, BFF/logout. We want to map remote BFF API endpoint. So whenever we make a request to anything under /API on the BFF host, those calls should just be forwarded right away to localhost 5002, where I am running my API. Please note I had two APIs, the goals and the weather API that I could call. Those two strings came from two different APIs. And I do not have to specify them here. I specify the root path. So when we alter our API, we can do that on the API host, and we can alter our JavaScript to call the new APIs, but we do not have to change and update and maintain an API list on our BFF. So this is a lightweight component from a maintainer's point of view. So that's it. That's all we have to do on the host. Let's go to the spa, and this is the funny part. Let's go here first. We have a callback HTML that was used as its target when coming back from the identity server in the redirect. Do we need that anymore? No. Do I have to create a similar one in the BFF? No, because the authentication middleware and authentication handlers have those endpoints built in. So using OIDC on the server side is much less ceremony than doing it on the client side. Do I need the OIDC client anymore? No. Do I need the silent renew page? No. Do I need the sites.js? Yes, please. My index, now we're moving the token handling to the server side. Remove the renew token and remove that one, OIDC. Site.js, what do we have in site.js? Well, the token renew button can go. All the OpenID Connect settings can go. That's nice. I just found out, remember, I have one thing I need to do too. The settings on the identity server are somewhat different. I need to update the identity server with the new URLs. We now have a client secret. We want to allow refresh tokens. I'm just updating the identity server, the same settings. So back to the spa. I have no user manager. I have this check if we are signed in. So let's go and have a look. We define a global variable. Is this a good idea with a global variable? Nope. Is this a demo where I can just be lazy? Yes. I want to call an API called BFF/user on page load, where I can check the result. And if the result equals for a 1, it means we are not signed in. If the result equals something else, we are signed in. So then I can get this one. So when we're not signed in, what happens is that the login button is displayed. When we are signed in the similar way, the log out button is displayed. The renew button is no longer there. And then we have this welcome text. That is a bit more complex, because we do not get a user object right away. I need to actually parse it from result. So JSON.parse the result. We parse it, and then user profile name. This is what we get back here is an array. So I can go to the array and check user.find. Find, and we have an element. If e.type equals name, remember that I said don't use XML names. I would have been more, saving me a lot of keystrokes here, right? So we can clear the old login detection. Login previously called the OIDC client user manager to sign in. Now it's very simple. Window.location equal /bff/login, right? Logout is a bit more complex because the logout endpoint requires a session ID to be sent, and that is another CSRF protection. So I need to actually go and find it. Window location is in user find element e.type equals bff log out URL dot value. The call APIs is also simplified. I mean, the previous version of the call APIs had to call get user and then the call APIs. This call API. To call an API previously had to get user and then set the request header with the current access token. I can do that much easier now. I do not have to call get user because the user handling is done server side, right? So I get this, and I actually just altered it a bit here. It shouldn't return text. And I need to unconditionally set request header x. Do you remember the evil kitten protection? XCsurf. And I need to set it to 1. And then send. And then when I call the APIs, I had 2 APIs. The goal API is only accessible when you're signed in. The weather API is accessible both in a public version and a non-public version. So the public version returns today's forecast, but not tomorrow's. And when we are logged in, we get both. So here I simply can check if user not equal null. If I have a user, then I can go ahead and call the API. The API is of course now on the remember I mapped it to /API/goal. And I can call a similar way the weather API. Should be called always regardless if the user is signed on or not. And it's also in the /API/weather. Renew is gone. You know, this excellent user interface with sign out, where I signed out of the identity server and it magically found out I was signed out and signed out of the application right away. That is doable with the BFF pattern as well. If we have server-side sessions, if we have a database storing the sessions, and if anyone has an idea how I can squeeze in a database in the 13 minutes I have remaining of this talk, please feel free. I don't have an idea of that, so I'm sorry, but I'm just dropping that part of the functionality for this demo. So that's it. That was a lot of code to write, which means any guess on how many bugs I have before this actually runs and works? I guess there's at least 2. Login button. I was logged in already, obviously. Okay, login button. Alice. Welcome, Alice Smith. All APIs. Goal for today is for 1. Okay. I did something. I missed something. You see the weather forecast, sunny and nice. Tomorrow's forecast is only available for logged in users. So I can call the APIs on the remote API host. They are proxied correctly, but apparently I forgot something to tell the BFF to include access tokens. So let's go back and have a look what I forgot. It's in the SPA. When I mapped the remote endpoints, I should tell it that it needs, and I have a cheat sheet with the require access token. Require access token. As need to supply an access token. And in this case, I have a smart fallback thing I want to use here, which is user or client. What this means is that whenever the BFF routes an API call to the back API host behind, it will always include an access token. If there is a logged in user, there will be an access token, so the API is called on behalf of the logged in user. If there is no user signed in, there will be a client credentials token authorizing the BFF to the API. The good thing about that is that in the next step, we can actually lock down our API, so the API is no longer callable directly from the internet. Let's see if this works better this time. You can call the APIs. Okay, let's see. We go here. We call the APIs first. Weather forecast 401. No. The API is not happy with us. How come the API is not happy with us? We have the right authority. And we have the... Let's log in and see if we can get through. I have an idea what I might have done. yeah, when we are signed in, we got it working. When we're signed out, there is, I guess the fault is in the config that the grant types, I set the grant type to be pure code. And it should, of course, be code and client credentials. We want our, we need to make, let's just close this. We need to make sure that our client is able to request an access token on behalf of itself when there is no user signed on. So let's see if I log out, all APIs, yes, it works. So now the BFF goes off, fetches an access token, an anonymous access token, but still proving that the call came from the BFF and can call the API. So it works. How many bugs were it? 3? 2 bugs? I guess 2. Do I get cookies now? I've handed out all my cookies. I don't have any more cookies to hand out. But we're not completely done yet. I want to go to and have a look at the API. Because when we look at the API host, this is the setup that we accept inbound tokens. Then we have the authorization policy to detect whether we have a logged in user or not. That is used by the weather forecast API. Then we have CORS, cross-origin resource sharing. Do we need that anymore? No, we can drop that because CORS is a concept for to allow cross-domain JavaScript calls, and now we're not doing that anymore. We are calling directly from the BFF into the API. And we can do one thing more. We can add a require authorization on the weather, the forecast, and saying that even though it's allowed to be accessible, both if you have signed in user and not, we don't have to allow anonymous access to the API. The API should only be callable by the BFF. So we're closing down direct API access from the internet. And one more thing. My weather forecast API is a generic API that a lot of services in my corporation uses, but the goal service is something that just my HTML show-off application uses. So I'm moving that simply to my bar. And as BFF API endpoint, I add that to say that I want this to be, I want this to have the XCServe requirement. Last thing I need to do is site.js. Now the goal API is available locally directly, right? So I cleaned it up, I simplified my architecture, I've secured my API from direct calls. It's only callable through my BFF. I have a much clearer view now who will call it. It still works. Yeah, it's a sound check for the festival or the concert tonight, and the NDC crew said that if this sound check started and was disturbing, I should just dance a bit and wait. I'm happy that it's not louder than I can still talk. If I log in, Alice, I can call the APIs and get everything. So we've taken our application. Let's see if I have the presentation still running somewhere here. So we've taken our application, our single-page application. We have found out that in the new modern world where browsers are locking down cookies, we need this architecture. Yes? Over here. No, I removed it from the API over here. So previously, before this transition, the client-side application called the API directly, and then I would need cores to allow cross-domain call. But now our API is only called by another server, so I can remove the cores. Yes, and the access token is kept on the BFF. The JavaScript side never gets the access token. The JavaScript uses a cookie that is HTTP only to communicate with the BFF. So I'm keeping the valuable tokens out of the JavaScript application. If a request needs to be signed by TLS signing, so if you need to sign, so that would essentially be this. You would still have the BFF to avoid cross-domain. Your JavaScript should not call any Azure API directly. Your JavaScript should only call your BFF running on the same host. And then you would need to, I don't know if you can use the proxy feature of the Duende BFF and add request signing. I think it might be possible, or you would have to create a separate API here that then calls the next API. Yes? Whose job is it to keep track of refreshing tokens? So let's see if we can bring up. You remember how long token lifetime? Do you remember what I said I used on this demo? So the API, the token here. Where do I have my mouse? The token should definitely be expired by now, but it still works. This is built into the BFF component. The BFF component's use is the identity model library for token management, and the identity model library contains automatic token refreshing. So when using server-side components, we can use the identity model library that will keep track. When an access token is retrieved, you get a lifetime back from the authorization server. The identity model keeps track of that, and if the expiry time has passed, it will automatically use the refresh token to get a new access token for you. So you never see that part of the handshakes. The refresh token is something that is gotten on the original sign-in from the authorization server. I do get the refresh token. Yes, at the back. So the access token and refresh token, where are they actually stored? That is a good question, and I'm feeling like I jumped. You know, I did a 2-day workshop of these concepts, and I feel like I kind of jumped over 1 day, 1.8% of the day, and just kept this part. So the short answer is that they are in the cookie, and the cookie is encrypted with data protection and a key that is only available to the BFF. So even if it's in the cookie, there is no way for the browser to read it and use it. And besides, the cookie is also HTTP only, so any evil JavaScript will not be able to read the cookie. If it is a good the question, if I got it, it's a bit hard to hear, but if I got it right, it was, would it be a good idea to store the tokens in a database or Redis cache? Yes, you should do that, because then you get server-side sessions, and then you can do server-side. You can invalidate the fresh token. You can you should revoke the tokens to sign out. There are more things to this, especially on the logout side, that I simply don't have time to show you right now. So one final question here. Nearly. So I'll repeat the question. So this is the handshake that happens. The server redirects the user to the authorization server. Sorry, I should maybe have this slide instead. It's the Pixie flow. So there is a front channel redirect back and forth happening first. What is actually passing over the browser is only the authorization code. It's an identifier representing the authentication happening. And then there is a back channel call directly from the server side to the STS to retrieve the tokens. The tokens are never exposed in the browser, yes. So if we look at this, the tokens are, all the token handshakes are happening entirely on a back channel. You just get this authorization code. It's a one-time thing, and also proof key code exchange contains a code verifier. That means that the server has a one-time secret that is needed to be able to retrieve the token on the first time. So even if you steal the code, or I steal the code, I cannot exchange it in any way because I need the code verifier that only the initiating server has. So I'm sorry, but I think we are running out of time, aren't we? And I guess I have another speaker that will be upset. So I'll be available if I continue. I will be available outside for any more questions. But thank you so much for having me, and enjoy your cookies.